Cool beans. Well, thank you guys. Thanks for coming today. A little bit of a smaller class. That's okay. Hopefully today's is going to be really fun. We are going to be going over Git. We touched on Git a little bit before, but we're going to really use it today, and we're going to get into the weeds, and we're going to start getting hands-on with it. And we're also going to talk about GitHub. Those two are going to go hand in hand. So that is, it's going to be very just focused on that. We're not going to really do much else. We're going to be using code, but we're not really going to be focusing on writing code. We're going to be using some HTML and CSS from your CSS homework. If you have that, like I said, if you don't have that, just create a temporary file or like a TXT file or an HTML file that's just from the template. You can access that through GitHub, through our team space. Yeah, and let's see. So I posted some resources into the general channel that most of you guys probably saw already. I just want to make sure that we have everything set up for everybody beforehand. Nathan, once again, I'm sorry, we'll get your Ubuntu going. But we want to make sure everybody has Homebrew, which is, we're not going to need that today, but we should have Homebrew installed, we should have Git installed, we should have VS Code installed. The links are all in general, if you need to go follow those to download those again. Some bonuses, something I talked to Travis about on the side when we were going over fixing his code dot command in the terminal to open up VS Code, are downloading something called iTerm, which is a replacement terminal. It's a much better experience when you're navigating the terminal. Like, I don't know if you guys noticed that, things were highlighted different colors in my terminal when we were going through the last lesson. And a lot of that comes from iTerm and using something called ZSH, which is a different shell program. We don't need to go into detail about those, but if you want some of that easier tab completion and a history of your last commands and the colors and the theming, and being able to see where you are, your current directory, like in the actual title of the terminal, you're going to want to download those tools. And you just need to open iTerm like an application instead of the terminal, and then you'll be able to do all the same commands and everything. So if you guys are interested, go ahead and get those guys set up. That'll be really handy in the future. Cool. So Git is what we're talking about today. Git is something called version control. So Git is how we are basically going to save our work and see what happened in the past, see what happened in the future. And sorry, I know I'm kind of beating a dead horse because we talked about this a little bit in the last class, but really getting this mental model of how Git works is pretty difficult. At least it was difficult for me. And I think that it's really an important one to grasp. So you'll hear you'll hear Git referred to as version control. And really that's just a overcomplicated way of saying, I can save different states of this. I heard an analogy to a video game, like saving video game states, which I thought was really kind of an apt analogy, where if you're playing Fallout and you make it to a certain point where you want to be the bad guy or you want to be the good guy and you've played neutral the whole way through, you can save right before you make your choice. And then you can kill everybody in the town and see what happens. And then you can go back and reload your save state before you did that. And then you can go in and be the good guy and save everybody in the town. And then you can go back into your previous save state and then pick which one you like best. So that is really basically how Git works. The way you travel through a video game through time, you make changes, your save file grows, and it's specific to you and what you've done. And then you can branch off or go backwards in time or forwards in time, depending on where you've been. So that's, I think that's a pretty cool mental model that I read an article about that shows Git in that way. So yeah, and you will hear it as version control. So you're controlling the different versions of your software using Git, and you can save things with it. Also, I don't think I mentioned, if you want to follow along with the lesson plan, I pasted that into the general channel. I pasted a bunch of crap into the general channel, but I think that was one of the last things that I sent before Sean and Sam took over and started pasting a bunch of crap in there.
What are you talking
about? So yeah, you guys can pull up that link to the GitHub Markdown file if you'd like to follow along. Okay. One other note on this slide before we move on is that the concept of Git, I think a lot of times when we're learning the command line, when we're learning web development, when we're learning all this stuff, is that everything we've experienced on our computer so far, when you think about a program, when you think about software, you think about the mouse, you think about the close button, the window, you think about what you can see, what you can click on, what you can interact with, forms you can fill out. So it's all very visual. Like applications up to this point have been a very visual experience for us when we use computers. And that's one of the things we're going to kind of break apart as we get into some of these tools we use as programmers, is that a GUI, a graphical user interface, the window you look at, is not always there for these tools because it just doesn't need to be, because you can use them with the command line. So Git is just a piece of software. And as software, it doesn't need to be something that has like a screen that's displayed with pretty colors and has buttons that you can see. So we're going to be using this software without actually looking at like a GUI of it. So I just want to keep that in your mind. It's like when we go to the command line and we use something, for example, we talked about Brew. So Homebrew, we talked about as like an app store where we can download things onto our computer. And that's kind of a foggy like concept when you think like, oh, it's an app store, but wouldn't the app store just be on the internet? But Brew is a piece of software that connects to the internet through your terminal, and it accesses a huge repository of different tools you can download that are all just text-based command line tools. So Brew is a piece of software that doesn't have a UI that you have already used. So I just want to kind of get the ball rolling as far as like that mental model goes, that not every piece of software has a user interface. All right.
Well said.
Thanks, Colin. Can't tell if you're being sarcastic or not, but thanks.
No, I just felt like you needed some response. So.
Oh, no, I was just reading and mumbling to myself. You're good. Okay, sweet. So GitHub versus Git. This has been like another topic that is kind of hard to grasp right off the bat. So like we talked about before, Git is text-based software. And this little picture on the left here, can you guys still see the screen? Okay.
Mhm.
Okay, great. So this picture on the left here is, a classic green text IDE, or not IDE, but using a terminal. Everything is text-based. That's our example of Git right there. Git is not the same thing as GitHub, but as we can see in this picture over here on the right-hand side, GitHub is very closely related to Git, as in that it is built on top of it, basically. So if we look at this, we see, there's little green lines in GitHub in this, pretty UI with the circles and the squares and the colors and the website and URL. But some of this data is coming just straight from what our example of Git was, which is just the Git application itself, the Git software that is that text-based software. So GitHub uses Git. It is built on top of it, but it's basically just a prettified version of what Git provides. So all of the power that GitHub has is coming from Git. All of the prettiness of GitHub is coming from GitHub. So GitHub cannot exist without Git, but Git can definitely exist independent of GitHub. It just doesn't have a user interface. Once again, similar concept to what we talked about, before with Homebrew, things like that. You can think of Git kind of as a system. So Git is a system for managing our code. It's for managing the history, managing the versions. It's a system that we work with. And a GitHub is a website that uses that system to host our code online. With the concept of systems, and I use the term wrapper down here, kind of thinking about Git as a system, and then GitHub as a wrapper around Git. And another example you can think of is Words with Friends and Scrabble, or Words with Friends and word tile games. So Words with Friends is a wrapper around the system of word tile games. It's a wrapper around the rules of word tile games, but it is not Scrabble. Words with Friends is not Scrabble itself, like the rules of Scrabble, the system of the game. And another thing, maybe I'm taking these analogies too far, but like if you're halfway through a Scrabble game, if you're playing a physical Scrabble game on a table and you're putting the tiles out, you know the rules in your head, you understand how it works, you understand the system of tile, letter tile-based games. So you can play Scrabble, you can make it, let's say you're 2 hours into your game with somebody, and then you accidentally bump the table and all the Scrabble tiles fall onto the floor and get spread everywhere. So you've lost everything. You've lost the state of your game. You've lost the point you were at. You're never ever going to be able to get back to where you were before, because it's all just gone, and it wasn't saved anywhere except for where you could visually see when you placed it on the table before. But if you're playing Words with Friends and your phone catches on fire and you lose it forever, you could just log in to Words with Friends on a browser on another phone and pick up your game where you left off before. So you didn't actually lose your game because you were playing with Words with Friends, which is a wrapper on the system. Both of those are Scrabble. Both of those are word tile games. But Words with Friends is something that is distributed, something that's on the internet, and you can log back into it and get back to where you were. So that's kind of similar to how Git and GitHub work. Git is just the system that we're using. Okay. I don't know why I chose Scrabble as the example. That was just what popped into my head. I don't particularly love Scrabble or Words with Friends, but okay.
Good job, Michael.
Yeah, I'm just gonna fish for compliments every time. How was that part, guys? Okay, sweet. So once again, lots of word vomit all over you. I don't want to just make this a diatribe about me talking about things and bringing up a bunch of random obscure metaphors. So the best way to learn Git is just to dive into it and to actually start using it, because these are just commands that you're going to use a million times in your life as a software developer. And you just got to start. You just got to start using them and make mistakes with them and learn how we can leverage the tool. Sweet. Okay, so what we're going to do here, once again, I'm going to beat this dead horse of the, we're going with Rick and Morty analogies now. So, yeah. Alrighty. So on the bottom here, can you guys see the screen with the spaceship and stuff?
Straight up.
Okay, cool. Great. Okay, so on the bottom here, we have a planet. It looks like a moon, but it's just supposed to be a planet. So we have a planet at the bottom. You can think of the planet as your computer. So on the left-hand side, we have our computer, and we are in a directory I created called Crystal Planet. So this is like the planet we're on, and this is our visual kind of example of it on the right-hand side. Up in the top right there, we have another planet way off in the distance. We're going to call that Storage Planet. And it's just full of like boxes and storage units, and it's completely a U-Haul storage center place. Storage Planet is what we're going to use as for our metaphor of GitHub. So we're going to think about Storage Planet as GitHub. And then down here, we have our computer. This might not have very good contrast, but so this is our computer, which is, some random planet. We have Rick in his ship here. He's coming down to the planet, and he is going to land on this crystal planet. It comes down and it lands on this planet. So what that looks like in the code, I know you're like, what in the hell is this analogy even about? So over here on the crystal planet, the first thing we're going to do is we're going to run git init. And actually, since this is taking me 100 years to do this, you guys can totally follow along and do this at the same time if you want. So basically, you can just create a directory, anything you want, just with makedir, so mkdir, name it something, and then cd into it. And you guys can follow along if you have Git installed on your machine. So on this crystal planet, the first thing we're going to do is git init. What this does is this is the initialization of Git, basically like in this directory. So it's saying, hey, Git, the software Git, use, I'm going to be using you within this directory. Like you're a part of this thing that I'm working on right here. So when I run git init, sweet, it says initialize empty Git repository in my name, Crystal Planet, and then this .git. Directories that or files that start with dot, or directories that start with dot, are actually hidden. So if we run ls, we're actually not going to see that. We don't see anything. It doesn't look like anything happened, but something changed, and Git is paying attention to this directory. We won't go into details about that, but basically we've just said, hey, this git init is like Rick coming down and landing on the planet. And we're going to think about the spaceship as Git itself. So the planet was our computer. This specific little area of the planet is our directory. And then Rick in his spaceship, the spaceship itself is Git. So when we say git init, it's like Rick landing on the planet here. Okay, and then what Rick came to the planet for, he came to the planet for some crystals. So in our terminal, if we wanted to start writing some code and start doing something, let's say we are going to create a file called crystals. I'm going to make this just a txt file, touchcrystals.txt. Now, if we can run our ls command, we're going to see that file there. Cool. And basically, when we did that, when we ran that touch command to touch the crystals, the spaceship here, because it has been initialized, is aware that there are crystals. They're going to appear here. They're not here yet because we haven't written any code yet, but there's like a potential for something that's happening. So basically the spaceship is just keeping an eye out for this whole area. It's looking to see what shows up around here because it's been initialized. Another thing that happened when we did git init is there was a storage crate that showed up that popped out of the spaceship. And the door opened on here. And then we have this ramp that came out. So when we did git init, the spaceship landed, it got pulled out this bin, this crate, and it opened up its doors. So Git is kind of ready to go. And then when we created that file, Git is now just looking and saying, okay, cool, there's stuff there. But it's not doing anything with it yet. So let's go ahead and make a change to crystals.txt. Now I'm using a command called vi, which is going to allow me to make a change right here in the terminal. It's basically just a text editor built into the terminal. It's a little bit of a pain in the butt to use. So you can definitely just do, we are going to create a crystal. We're going to create a kyber crystal, and we are going to create some kryptonite. Just to, tiny little bit of superhero shout out. Okay. Now remember the cat.
You created kryptonite, but it's okay.
Oh man, that's good. Okay, so the cat command is how we can check and see what's in there. Okay, cool. So our file changed and we added some crap in there. So did you guys notice anything in the terminal that changed when we like were making some of these last few changes? Not a big deal if you didn't.
Red X instead of the green dot.
Yeah, exactly. So this is one reason that downloading ZSH or iTerm and iTerm, most of this is coming from ZSH though, is a really cool, it has some cool accessories you can add on. So one of the things is in this theme, it basically knows whenever I have initialized Git. So see when I did Git init, before this, it was just normal. It was just saying, okay, cool, you're in this directory, blah, blah, blah. And then as soon as I initialized it, then it said, oh, you're on Git master. This is a branch. We're going to talk about branches in a sec. So it says, oh, you're on the branch master. And here's a little green dot saying that everything is good to go. So Git is aware of everything. There's nothing has changed, nothing new. And then as soon as we made this crystals file, it was like, ooh, something changed. And it gave us this X. And it says, okay, Git is aware of a change that happened that it hasn't taken action on yet. And we're going to take those actions in the near future here. But this is something that's really handy and something that I lean very heavily on. When I'm using Git in the terminal. So having this is really a cool feature. And I definitely encourage you to download ZSH and iTerm, which those links are also in the general channel, if you can. Okay, so now that we've created those two files, we actually have crystals on our planet. So let's say that kryptonite is this one. And I know it's not green, but just bear with me. And then let's say that the kyber crystal is this one. So we have two crystals on the planet. Cool. And let's say Rick got out of his spaceship at this point.
How
Rick's
do you tell the iTerm that you're done adding text?
Oh, did you mean VI?
With the VI, yeah.
Oh, sorry. Yeah, I didn't go over that. You can definitely do it with the code command. You could do code crystals.txt, but if you're already in VI and you're stuck, so what you do, so when you go in here, the little tildes just mean like empty space. It just basically means white space. And then you notice that you can kind of move around with the keyboard, but you can't do anything. So you have to hit I to insert. So you hit I to go in insert mode. And then when you hit I, you can actually start typing stuff and like it'll show up. And then when you're done, you have to hit escape. And escape kind of takes you back to like the previous mode where you can't add stuff. And then to save it, you have to hit hit escape, colon, and then WQ, which
right quit.
Wait, what is it, Sean?
Right. The W is right and the Q is for quit.
Right quit. Awesome. That's great. I did not actually know that. I just knew the command. Yeah. So right and then quit.
Okay.
It's not simple. It's not straightforward at all. But
no,
WQ will save it.
but cool.
Way easier than the
Cool. So we created our crystals. We see those there. And then if we wanted to kind of check and see what Git sees, we kind of want to see this directory with this one file with 2 lines of code in it. We can kind of see how Git sees this, and this is going to be how this knows that to change this from a green dot to a red dot or a red X. So to do that, we're going to run a command called git status. So if we run git status, we're basically just saying, hey, I want some output that's going to tell me what Git sees. Like, what is Git seeing that's happening? Okay, so we see, all right, on branch master. We're going to talk about branches in a sec. Don't worry about that. No commits yet. Okay, we're going to talk about commits in a second. Don't worry about that. This is some good information, though. So we have some detailed pieces. We have untracked files. So git add file to include what will be committed. And then we have a red crystals.txt. So we have our file in red. And this says nothing added to commit, but untracked files present. So one thing I want you guys to keep in mind, I know we've probably talked about this a little bit, but when you run a command and it doesn't work or it gives you a lot of output, it's really important to read it. Just read it. As long as it's not like 100 pages long, try to read the whole thing and try to kind of, if there's words you don't understand, go ahead and just skim over it, maybe, but just try to read the whole thing, see if you can get some piece of information out of it, because this is really all you have when it comes to Git. When things work correctly, they often don't give you any output. And if you need to check stuff, you might have to Google like the right commands to run, and then you're going to get, output that it didn't work in the terminal. But sometimes those errors give you pointers to the right direction as to what you can run. So I just encourage you to read your output when you get things like this, and especially when you get errors, because errors are there for us as developers. They're not the give up flag. They're basically a clue, is the way that we should think about errors. And this isn't an error. This is just piece of information, but it could look like an error. So we see crystals is red. And it's saying that because it's untracked. So we have a few pieces of terminology here. So we have branches, we have commits, we have untracked, we have commits, untracked files. And if we look over here, you remember how we created this little bin? So we have this bin, and this is basically how we are going to track files. So let's give this a name. Let's call that little bin a tracker. So this is like Git's tracker. And this is attached to Git, basically. This little bin is part of the ship. It's part of Git, and this is our tracker, is what we're going to be naming this. So if we want Git to know that these crystals should, be taken with it, basically, because we want to put those into GitHub, we need to put them into the bin. We need to track them. So to do that, what we're going to do is something that it actually told us here. So it said use git add to track. And it's like, okay, cool. So if we do git add takes one operand, takes one argument, and that is a file or a directory. And in this case, we just have crystals.txt. So we're going to use our tab complete to put that in there. So now when we run git add crystals.txt, we are adding crystals into the bin here, into the tracker thing. So let's go ahead and do that. So now our kryptonite and our kyber crystal are in the bin, because Git knows that these are going to be something that it's going to be carrying with it, but it hasn't been added into the ship yet. It's just kind of in that bin. So if we run git status again, git status is really, really important. Git status is going to tell us what Git knows. We see what changed. We see that we are still on branch master. We still have no commits because we haven't done anything with the commit command. But instead of saying untracked files, use blah, 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 with the red file name, we see changes to be committed, git rm -- cache, blah, 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 to unstage. So it kind of is like, okay, if you want to undo what you just did, you can do this. And then it says new file in green, crystals.txt. Yeah, what's up?
So is that git remove cached file to unstage, does that essentially just mean removing the file from?
Yep. Yeah, exactly. So Git has an attachment to this file now. It says, dope, you have added this to Git. You have added this to my bin. So Git knows that it exists, and it knows that it's important, and that it is going to keep an eye on it. It is going to be tracking that file. And tracking is a term you're going to hear a lot when we talk about Git. So yeah, git rm -- cache file. I think the cache is basically just saying like if there's any remnants left behind, like any pieces. So git rm cache file is going to say, oh, I'm going to unstage it. And there's a lot of annoying terms that aren't very consistent in terminology, in like their analogy, but like staging and unstaging are other terms. And when we talk about the tracker, we talk about this little bin here, I'm going to give it a better name, actually. Let's call this the stage. When we see that this says here to unstage, which basically means to take it out of the box. So
Cool.
we could take it out of the box with unstaged because this is our stage here. So thanks for that, Sean. That's yeah, that could have been a misleading term.
Thank you.
Okay, sweet. So our crystals are in the thing, and we know that because we ran git status. And we can kind of imagine this as if Rick is blind and Rick can't see anything that's happening. He doesn't really know what's going on until he runs git status. Git status is like the lightning strike that lights everything up so he can see where the state of his world at that point in time. So git status is super important. You can run it as many times as you want at any point in time. I run it after almost every single git command I do. Because if you don't, you're kind of just flying by the seat of your pants. You're assuming that everything went well. And eventually when you're running very simple git commands that you're confident they're going to work perfectly, you don't always have to, but I pretty much run it after every single git command I do. It's just git status. Tell me where I'm at. Tell me what just happened. What did I do? Okay, cool. So git status to see where everything's at. And then next up, we see here, we've seen some output talking about commits. So if we're going to commit this code, if we want to say, I want to put the crystals into the spaceship because like I'm kind of done tinkering them with them, because at this point Rick could take this out. Like he could take this crystal out, and mess with it. He could, break it in half and then put it back into the bin. And it's that only that half of the crystal is going to go in the ship eventually, because he can still change these. These are editable basically. This is like the ship is keeping an eye on those crystals because it's in its staging box in its container, but they're not frozen in time yet. So let's say we're absolutely certain these are the only two crystals that he's going to want to take with him on this trip. So let's put them into the ship. So to put them in the ship, into the git ship, basically, we're going to say git commit. And we're going to pass does anybody remember what this is called when you do a dash and then a letter when you add a little thing like this to a command on the terminal?
Flag, right?
Yeah, exactly. So we're going to add a flag, a -m flag, which this stands for message. And we could do this without the -m. We could just run git commit, but that's going to open up VI, which is, as Travis just learned, a little bit of a can of worms. But basically, we're saying we're going to commit these two crystals, and I'm committing to putting them in the ship. But usually you want to put a message attached to that, which is kind of like a note, almost like a receipt. So we're going to say git commit -m. Added two crystals, and code speak, I would say, added two new lines to crystals.txt. So that's our in-universe answer, and then that's our programming answer. The added two new lines to crystals.txt is a little overly verbose, but we didn't do much, so we can do that pretty easily. So that's a string. So we say -m flag for message, and my message is this. So when we run this, it says, okay, what do we get? We got master, root commit. We got a bunch of numbers and letters, and those are in brackets. And then we see added two crystals to ship. And then we see added two new lines to crystals.txt. And those new lines, those two things we added in. So one file changed, two insertions, which is what we inserted. We inserted those two lines of text, the Kyber and the misspelled kryptonite. And then created mode, blah, 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 crystals.txt. So this looks like a lot of information that got spit out here, but basically this means everything went fine. So we got what we needed. And then what do we run if we wanted to see if we want to see through git size again? Do you guys remember that one?
Yes, just a second. To see the status, doesn't it just get status?
Yeah, exactly. So I'm going to run git status because I do that every single time. Git status on branch master, cool. Nothing to commit, working tree clean. Okay, so it threw a little bit more terminology at us. We say, okay, now there's nothing to commit and our working tree is clean. So, okay, interesting. Working tree right now, let's not worry about that too much. Working tree is basically just like, kind of like the alternate universe that this planet is in, or the current reality that this Rick is living in. This is C137 or whatever, as far as Rick's reality. That was a bad analogy. We'll get there. Hopefully it works out better in the future. Okay, cool. So it looks like everything's fine. Seems to be good. We have a green dot. So we went from a green dot to a red dot to a green dot. So what do those mean? That basically, and we saw that too when we did our git status. So we saw the red text and then we see green text. And if we had done it before, there was really nothing here, so it was green. So the reason that is because Git was saying, I am aware of everything. You have not done anything that I don't know about. And then it was like, oh, you did something that I'm not aware of. Like I saw you walk out the door and I saw you do something when you left the spaceship, but I don't know what you did. So tell me. And then we said, okay, cool. Here you go. I'm going to add these in. This is what I did. So this is basically you open the spaceship door, Rick pokes his head in and says, this is what I'm doing. He puts it in the staging area. So he has staged his changes by putting them in the box. And then the ship is like, okay, cool, I'm happy. Now I'm back to green because I know what you did. You told me what you did. I'm aware of it. Sweet. Cool. And we committed those. And when we committed those, we basically took this whole staging box and we put it into the ship. We sealed it up. We closed the lid. Our crystals are inside of there, safely packed up. And the door is closed. And all of that crap is in the ship. It's inside of Git. So when we did commit, we said, okay, cool, boop, close it all up. You're in the ship. Our crystals are in there. And then we also put a little timestamp on there. This is something we don't need to worry about too much right now. But we basically said, you know, what time did this happen and like when did it go through? And when we did our commit message, that was kind of like a receipt, like a little piece of paper we put inside the box and it said, you know, I'm just leaving a little note about what happened here, what's inside the box. And then the barcode that we slap on the outside is basically a timestamp. And that's something that automatically happens. We didn't have to do anything in particular, but that is like the core of Git is the automatic timing of things to say, okay, you added this into the ship at this point in time. So I know that, you know, this is like our first video game save. So when we make a trip off to Storage Planet, sorry, you can't see that. When we make a trip off to Storage Planet and we come back, we're going to be making more saves in the future, more like video game saves. So now we have all the crap and our crystals inside of the spaceship. So what we need to do to launch our shuttle to actually go and make it to Storage Planet, to make it to GitHub, is we need to push is the command. So what we are going to do is we are going to type git push. So git push is the command that is going to take everything that we've bundled up and it's going to send it to GitHub. Okay. So when we hit enter here, did this work? Fatal. No configured push destination. Either specify the URL from the command line or configure a remote repository using git remote add blah, 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 and then push the remote name, git push blah, blah, blah. So basically what this is saying is that it has no idea where it's going. So at this point in time, what happened is we said, cool, we have our stuff, we're ready to go. Let's go to Storage Planet. But Storage Planet says all of these little addresses are allocated to somebody. Somebody said, hey, like this is mine, this is mine, this is mine. All these people own these little places on Storage Planet. They say these are locations that have my name on them and I have created them and they are ready. When we did this, we just came to this planet, this random planet, gathered up some crystals, and then we're trying to launch to go to Storage Planet. But Storage Planet is like, you do not have clearance to land because you don't have property here, basically. So it has no idea what we're trying to do, has no idea where we're trying to go. So what we need to do first is we need to make a call to Storage Planet, and we're going to do that with GitHub because that's our Storage Planet. And we need to basically buy some property and set up an empty warehouse where our crystals are going to live. So to do that, I'm going to go ahead and just do this in mind. So I'm going to create a new repository. And a repository is basically these little boxes that I've created here are the repositories where our code is going to live. So I'm going to create a new one, and it's going to be called Rick's Crystal Storage for Rick's Crystals. Okay, creating repository. we have just opened the doors of our new warehouse. So we have a warehouse on Storage Planet now, and it is Rick's Crystal Storage. That's awesome. So GitHub actually gives us a lot of help here. It says, okay, quick setup, have you done this kind of thing before? No, we haven't done this before. Okay, or create a new repository from the command line. We already created our directory though, right? Because we already have Crystal Planet here, and then we did our git init, and this is our directory. So probably not that one. Or push an existing repository for the command line. Okay, that sounds more like what we want to do. So let's just click this little copy button here, and let's just take GitHub's word for it. So if we go back over here, we're basically fixing this problem here. So no configured destination, specify the URL, configure a remote repository. So we're going to say, okay, let's fix those problems. So git remote add origin. When we say remote, Remote is like basically, like the word implies, distant. So you use a TV remote to turn on your TV because there's distance from you and the TV. When you're working remotely, you are not physically there. You are remote. A remote location is something that's far away. So when they chose the word remote because it's basically like storage planet is very, very far away from this planet. It's not even on this planet. It's a different location. So the remote is where we can actually store things on GitHub itself. So remote is like, let's say, okay, this URL, my name / rickscrystalstorage.git, which is a brand new place that I made. And then .git is a specific file that this Git software needs and uses and was automatically generated. So we're basically saying, let's make that connection. I'm going to, communicate the coordinates to Storage Planet from the spaceship and say, yo, okay, I bought property. I have a warehouse. Cool. And now you know about it. So the next time I try to launch to go bring more crystals to you, you're not going to tell me that I can't do it because I already told you I have an address there. So that's what this is saying. And then we're saying, okay, git branch -m main. And we're not talking about branches yet too much, but we're basically saying this is kind of the version of reality where this is all happening. And then we're saying git push -u origin main. Okay, that's just saying git push. Don't worry too much about this U. That means upstream, which just means we're going back up to GitHub. And once again, there's a lot of commands here. There's a lot of things happening. I don't want you guys to worry too much about all of the specific details. In the lesson plan and in the homework, I've very specifically laid out about 6 or 7 commands that are the important ones to remember that you are going to be using in the homework to actually practice. So if there's pieces here, you're like, okay, this is too much. I'm not gonna be able to remember that. Don't worry about it. We have it laid out for what we do need to learn. Okay, so we ran our command and we see enumerating objects 3. Okay, cool, done. Counting objects, cool, done. Writing objects, cool, done. Total 3, cool. Oh geez, I click on a thing. And then we see here a delta. That's fun. So a delta is actually the difference between 2 things. So like if you had 1, 2, 3, and then 2 and 3, the delta would be 1. So there is no difference between what happened before and what happened now because this is our very first one. And we see where we're sending it to our address of our storage garage. And okay, we made a new branch, just the regular old main branch. And we see, okay, cool. I actually see that there's a branch here named main now. So this git : changed from master to main because we told it to set the branch up like that. And we can see that here because we said git branch -m main. So we're setting up the main branch there. And that was just the wording that GitHub chose. So that's how it got set. So branch main instead of track remote origin branch from origin. Sweet. So it seems like we actually made a connection now. Now at this point, our code is there. And if my computer catches on fire, I can buy a new computer and I can get my code back from Storage Planet. I can go take it out of there. So if this whole planet explodes, our crystals haven't disappeared because they're actually on Storage Planet and we can access those from anywhere. So if we go over here, when I refresh this page, what do you guys think we'll see?
Your code.
Exactly. So we refresh the page.
And then there's a note.
And we got crystals. Yeah. And that's really cool. So we can click on it and we can see awesome, Kyber, Kryptonite. Awesome. So we see the 2 lines of code. We see added 2 crystals to ship, added 2 new lines of crystals.txt. Sweet. So we see this Rick's crystal storage, which is what we named our GitHub repository. And then we see our file that we added. So we have made this connection between our computer and the broad, wild, wide internet, which is, I mean, that's pretty cool. That's pretty cool. Obviously, our example is extremely contrived, but we've just done something that allows us to save our code off of our computer, off-site, away. And that's really, really helpful. And it's helpful for a multitude of reasons. And one of the things that we are going to talk about how this is going to help us is, first of all, let's update our analogy here really fast. Let's move Rick and his ship off. We took our stage box with all of our stuff that had been packaged up and we offloaded it. So that's been offloaded into a little warehouse here. So let's say that landed here. So let's say this is Rick's crystal garage. So now way off there in Storage Planet are these little 2 tiny crystals that live there now. So they're good. We have those there. That's awesome. Okay. So now let's talk about one more of the awesome benefits of what Git can give us, and that is collaboration. So in Rick and Morty, there are tons of Ricks. People are all over the place. So let's say Sean is another Rick. Let's pretend Sean is another Rick from another reality. Sean shows up and lands on Planet Storage, and he's just perusing through all of the stuff, and he's looking at all the things, and everybody's a Rick, so everybody's stuff is kind of everybody else's stuff. So Sean's perusing, and Sean, why don't you pretend to be a Rick perusing, and I want you to navigate to this URL on GitHub. I'm gonna Slack it only to you. So secret. Okay, so Sean's Rick is walking around looking at stuff, and he stumbles across Rick's storage garage, and he's like, this seems interesting. And Sean sees that there's 2 crystals in here, and he's like, oh, that's nice. He's starting a crystal collection. I love that. But Sean's Rick has a bunch of blue crystals back in his garage. And Sean's like, you know what? I should add mine to this because I have some great ideas for what we could add to this crystals.txt file. He has blue crystals, and I like pink crystals. So Sean says, I want to add something to this. So what Sean is going to do is he flies his spaceship up to Storage Planet, and he says, hey, can I take, a copy of those crystals with me back to my garage workshop, and I'm going to add my crystals into them, and then I'm going to bring them back over, and then we're going to have pink and blue crystals inside of there. So to do that, Sean is going to take a copy of this, and he's going to clone it, which perfectly aligns with our sci-fi theme here. So cloning is the Git term for taking a repository, completely duplicating it, and pulling it down onto your personal machine. Now, there's 2 things. You guys may have seen this fork button up here. So you remember when we clicked fork?
Mm-hmm.
So forking is a little different than cloning. They may sound similar, like the same thing, but forking is basically saying, hey, I like your idea, but I don't want to contribute to yours. I want to do my own thing. I'm going to steal it. So you stab it with a fork, steal it off of their plate, and you never give it back. So forking breaks the connection between the storage planet and your computer, but it gives you all the code. So then you can do your own thing and create a different branch of it. Like, I don't know if you guys remember that, PUBG was built on some video game. Sean, what was the name of the original game that PUBG was built on?
Oh man, I have no clue.
There was some first-person shooter that was, yeah, but I don't remember the name of it either. But PUBG, like they basically took the code base for some first-person shooter game and they started making mods on it. So they basically forked all the code and they made a bunch of mods so that it was different. And the game changed so much that it eventually actually turned into PUBG, and they published the game as PUBG, but it was built off of a fork of another repo. But that was a fork because they never pushed it back up. They never merged it back with the original code base and said, hey, here's my blue crystals. You can merge with your pink crystals. They said, I'm going to make my own video game. So a fork is like that. A clone is saying, hey, I like what you did and I want to contribute to it. So I'm going to clone it, and then I'm going to keep that connection to Storage Planet, to your address, so that I can add my crystals into my bin. And then when I send it back up, it knows where to go, and it can go back up to yours. And you can decide whether or not to accept my crystals into your bin or not. So we're going to be using clone. So Sean, if you can go ahead and why don't you actually just share your screen?
So I should not fork it, right?
Don't fork it. Yeah, because unless you wanted to steal my crystals.
Going Zoom from I'm not forking it, right? I'm just downloading the code.
So yeah, so what Sean is going to do is showing us right now. So you click on the code button, which is like, okay, cool, GitHub.
Oh wait, I need to do Michael's. I kind of copied exactly what you did. So I have a crystals.txt. Is that going to affect anything?
No. It's because you have your own storage garage. You just happen to name it the same thing, So it's like 2 Starbucks right next to each other that have the same name, but they're actually different locations, different addresses. So what we're going to do here, when you click that clone button, and good catch on making sure that it was my repo. So that there's 3 options. We have HTTPS, SSH, and GitHub CLI. So I don't want you to worry too much about that. These are just ways that you can do it. Those are authentication, basically. And Sean could actually talk a lot more about SSH and HTTPS because that's more up his alley. Do you normally use the GitHub CLI, Sean?
No, I was just curious. I don't really know much about GitHub, to be honest.
Okay.
So.
I have never used the GitHub CLI either. Generally, HTTPS and SSH. And really all that means is basically saying like, yo, are you a GitHub user? Let's make sure you're authenticated. And if this was protected, if I put a padlock on my warehouse, on my crystals warehouse, I would need to give Sean a key to access it if he wanted to ever bring a copy somewhere. But I didn't put a padlock on my crystals warehouse because I trust all the Ricks in the universe. So I didn't put a padlock on. So when he says HTTPS, that's really just going to say, I'm going to authenticate you. And it's going to say, oh, okay, but there's no padlock. So as long as you're a GitHub user, you can have this code. But if I put a padlock on there, it's going to be more secure and say, you need to have been given access directly by Michael Brierly, the user at GitHub. So we're going to do HTTPS because that one's a lot easier. And he's going to copy that link. And really all this is, and we'll see it when he pastes this in, is that is really just an address. That is the address to our storage unit on Storage Planet.
Am I doing that
and
in
that's
here?
mine. Yep. So what we're going to do here is I would go ahead and git push. Goodness.
What?
Oh no, I was just messing with you.
Commands.
Oh, I thought you ran that already. So
Yeah.
I would go ahead and cd ... so that you can get back out of Crystal Planet and get into Dev Delta, and then maybe create a new one that's called like, you know, Michael's Crystal Planet, Michael's whatever. Perfect. That's even better.
Cuckoo.
Fuku, yes.
Okay, now it's cd into Fuku. Perfect. And what we're going to do now is we are going to clone down the code. And if we go back over to GitHub, it kind of told you what to do if we look at that. So actually, you know what? Never mind. It didn't tell us what to do. Okay, I'll tell you guys what to do. So go back over to the terminal. So it gave us the address, but the way to actually get it is with git clone. So git clone is a command. So you're going to type clone and then space, and then paste Command V or that. Yep.
For some reason, my
now
was not working before, so I have to do that.
Oh yeah, no worries. That's totally fine. Okay, so if we do git clone, so when Sean runs this, it is going to be a clone, like a duplicate of all of that. Like this is allowing his computer, his planet, the little random planet that Sean lives on, Sean's Rick is on, got the address to my storage unit, and he told his ship. So he sent his Rick ship off to Storage Planet, and he gave him the address. And he said, okay, go to this address, and then I want you to take a clone. And then the ship scanned everything in the warehouse, and it completely created a physical duplicate of it, put that bin into his ship, and then he took off and went back off to his planet. So now Sean's back on his planet, which is his computer, and he has it. So now when you go into that Rick's crystal storage, go ahead and type ls, and run the cat command on those crystals, make sure our crystals are there. That's so cool. So this seems trivial because we only wrote 2 lines of code, but this is huge because what Sean has done is he has taken the code that I wrote and all the way across the country, pulled it down onto his computer. So literally these were bits of information that only lived on my computer seconds ago. That this was code I could only access through my machine. And then I used GitHub to leverage the system of Git, the organization of our code that is the system of Git. And GitHub is just Git on the internet. So we used GitHub and said, okay, cool, I'm gonna put my code up on the internet. And GitHub gives us this awesome organized UI, this website that has a system of storing our code. And it lives up there. And then I can say, hey, this is open, this is free, this is available to people. And Sean's another developer and he found my code and said, I like that, that's cool. I want to add to that, I want to contribute, I want to give to that. He pulls that down to his machine. He has a copy of my code. And we both have a thread of connection that goes back to the same repository, to Rick's Crystal Garage under my name in GitHub. So we both have a connection to the same location, but Sean has my code and I have the code. So let's see what happens if Sean wants to change it. So Sean, why don't you go ahead and add your blue or your pink, your blue crystals. Blue is just for the visual metaphor, but oh, is this, did you VI? I thought you loved Vim. Oh no, this is Vim.
Yeah, it's okay. Sorry, but I didn't realize VI is way better on Mac than it is on Linux. on Linux, you have to use like H, J, and K to navigate.
Oh yeah, that's rough. That's rough. Okay.
So
it looks the same actually.
It is the
Sure.
exact same. I tested it out. Blue.
Oh, blue Kyber. Okay, sweet. Yeah, what else we got?
Nice.
Oh, dark crystal. Yeah. Okay, very cool. :WQ, so he saved it. And then just to be extra careful, yeah, do you want to cat that out again? Run the cat command on it just to make sure that those showed up. Okay, sweet. So we see that your changes happened. So this is cool. So before you run your next command, we see that Sean doesn't have the green and red. He has a little yellow. So you guys see that? So he was on Git main, the branch main, and then he has a little yellow guy there. And it's our yellow X. And now let's go ahead and run a git add. Or yeah, great, git status. Okay, perfect. So we say git status. We see we're on the branch main, and then we see git add. So git add, and then
whoops.
I'm really glad you did that, Sean. So before you move on, let's take a look at this. So can you figure out your problem by just reading what Git told you with your output? And it literally gives you hints.
Yeah, I didn't give it anything. I just said git add. I didn't tell it like what to add. And is this also where we put the message too, or is this just where?
Nope. So this is we're basically just picking up the crystals and putting them in the container. So we don't write the message until we put the receipt and seal out the box and throw it in the ship. And that's our commit. So
what I'm adding, right? I need to specify the crystals.txt.
Exactly. Yep. So you need to specify which file or directory, and that's basically which crystals you're picking up and putting in there. And you don't have to do all of them. Like if we had 100 files here, maybe one of those files is like your notes, like Sean's notes for his personal information, and he doesn't actually want that to go up to GitHub. He could just leave that one out. He could do git add all these other ones and leave some out, and that's like leaving the crystals on his planet, and they're not coming with him in the ship. They're just staying on his computer. So you can specify, and that's where git add is handy, because you don't always want to put everything in your ship to go back up to GitHub. So we're just adding this crystal file. It happens to be our only one in this directory. So go ahead and run that. Okay. And now we run a git status again. Awesome. It turned green. Sweet. Which really is all you need to look for to make sure that that worked. So it changes to be committed. Awesome. So now let's do a commit. Git commit.
Git commit.
And then we're going to do dash the flag M. So dash M and then space and then quote. And yeah, your message. So this is you're writing your receipt for what you're doing. Your little note that's going with your staged package. Cool. And then end quote.
Okay. And then that, and then is there anything else after?
Nope. So that's how we commit. So we're doing git commit dash M, which is for the message, and then we hit enter. Sweet. Okay. Committer, your name and email address. We're configure our macro. Blah 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 blah. Okay. Now. Yeah. Don't worry about it. So this is probably because it's the first time you're really running these commands. So it's possible that they are incorrectly formatted and it won't allow you to push up to GitHub if your like login information that it configured from your machine doesn't match what GitHub has. So let's run a git push and see what happens, and we'll use those little hints to fix that if that's the problem.
Git push.
Yep. So git push. This is so. Yeah. So when you actually run git push, you can specify and say, I want to go to this address. I want you to send the code to this address. But by default, when you clone down a repo and you get into it, we have git initialized in this Rick's Crystal Storage Garage directory. So by default, it knows, it says, okay, cool. When you pulled this repo down, I know the address. I gave you the address. And remember, that was the remote. So we talked about the remote URL, which is basically the URL that lives on GitHub. So when you say git push, by default, it says, do I have a default remote URL? If I do, I'm just going to send it there. So when you just say git push now, it's just going to automatically send it back up to my root.
It won't send it to mine, even though I made one?
It what?
It won't send it to mine?
No, and the reason is because where are you in your current working directory?
Oh, I'm in Rick's Crystal Storage, so I'm in yours.
Yours? Sorry. Where your directory?
Well, yeah. So mine was in I forget exactly what it was, but yeah, it wasn't in this one. It was in another. It was in my own, and I forget what the directory was. But should I just put it now?
Yep. So you can run git push. So hit enter, and that's actually a good point. Is that and we'll talk about this in just a second. That's a good point. So when we ran git init and when we initialize the repo, it really just does it by directory. So it doesn't initialize like your whole computer, because it's basically like where you landed your ship. So where Rick's ship landed, what it sees in that small little area, and that's basically the directory that you're in. So that's what it's keeping track of. It's not keeping track of everything on your computer, because I know you would be sending your whole computer up to GitHub, which is definitely not what you want to do. And you can accidentally do that. So careful where you initialize Git. Make sure it's just in the repository that you want it to be initialized in. So Sean had a problem. Permission to blah, 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 denied Sean McKnight. Unable to access crystal storage.git, the requested URL returned an error. Sean is on the main branch. So when we think about the crystals and the code and how he took those onto his ship and back, and then he made changes to it, and then he pushed that back up, he's basically requesting, when he did that git push, and it failed because he doesn't have the right permissions, but he's basically saying, I want to push my changes straight into your bin. I want to put my crystals right into your bin, and I want to change that immediately and say that, crystals.txt on GitHub over here is going to have, when I pull that down again, when I check for anything that might have changed, it's immediately going to bring his changes in. Sean could have deleted all the code and done something really nefarious that messed up my project. And if he was able to just do that immediately, and just to be able to push it up and say, I'm removing everything out of it, I'm screwing it up, and then pushing that in to this main branch, that would suck, because then everything is pretty much toast. I'd have to go back in time, and it could have messed up where, what other things I had been working on. So that's where branches come into play. So branch, and this is the whole reason I use the Rick and Morty metaphor. And once again, it might be way too layers deep, but like Rick has a portal gun. Rick's portal gun, he can open a portal and he goes to an alternate universe where everything is like similar or identical, but one small thing has changed. He uses his portal gun to travel between alternate realities. Branches in Git are kind of like creating an alternate reality where things are very similar, and you can make changes. And if Rick kills somebody in an alternate reality, that same person isn't dead in Earth's reality, right? And C137. So he can go back and forth between realities and see that dead person or the person alive, the dead person, the person who's alive. So it's kind of like that when we create branches. So what we need Sean to do is we need Sean to open his portal gun. We need Sean's Rick to take out his portal gun, open a portal, and move through it to another reality where he can make changes to his crystals that don't impact mine until he asks me if those changes are okay, by opening the portal back up, coming in, showing me the bin and saying, hey, is this cool? Like, can I do this to your crystals? And then I'll say, sweet, awesome, sounds good. And then we're gonna merge those two realities together. So for Sean to do that, what we're gonna do, and we'll have to solve this git push problem in a second, but Sean is going to create a branch. He's gonna pull out his portal gun, he's gonna open a portal, he's gonna go to another alternate reality. So go ahead and run the command git checkout space -b flag B, and then space, and then a name of your alternate reality, a name of your branch with dashes. Make sure there's no spaces in it. Whatever you want it to be.
Okay, Sean. Like this, you mean?
Exactly.
Do I need to flag it, or?
Oh, sorry. It doesn't need to be prefixed with a dash, but if it's multiple words, it needs to have
I got
dashes between.
Perfect. World.
Perfect. That's great. That's really good. Okay, so git checkout. Checkout is the term that we mean. If you imagine Rick pulling out his portal gun and opening a portal, that's checkout. That's git checkout. It's saying I'm about to create a split reality. I'm going to copy over this work into another universe where everything is the same for now, but I can make changes that don't impact the other world. So that's what git checkout is. -b is branch, and git checkout means you can check out other existing branches that have already been created and go navigate back and forth using that command. The -b flag basically says, hey, I'm creating a new one. I'm creating a new alternate reality. So -b is a new branch. And then Sean's -world is the name of it. So git checkout -b. Git checkout -b creates a new world. Git checkout allows you to use your portal gun to navigate between existing realities. So, and maybe, sorry if I'm mixing the metaphors too much, but go ahead and run that command. And once again, if you haven't watched Rick and Morty, it is really hosed. Okay. So,
sorry to interrupt. Sean, could I be a pain and have you zoom in on your text?
Yeah.
Command plus.
It's just like command plus.
Oh.
Yep.
Is that good for you, old
There
man?
we go.
Yeah, thanks.
Okay, so what do we see that changed? Do we see that git colon, that text changed, right?
He's not in main anymore. He's in Sean's world.
Exactly.
Sean.
So now we can kind of see that main, that text we saw before that we didn't really understand, that was the current reality. That was the current universe we lived in, our current reality. And then as soon as Sean pulled out his portal gun and said, I am going to take my copy of these crystals and I'm going to bring them over into an alternate reality. He said, now it's Sean's world. He created a branch. He branched off of that reality, and everything is identical at that point in time. So right now, Sean's world is identical to main. So those two branches are exactly the same. But if Sean makes a change in Sean's world, it's not going to change in main. So that branch, that reality stays the same because Sean's not there. He's not there with his stuff. He's not doing his things in that reality. He's doing it in Sean's world. So go ahead and open that file back up, Sean.
Okay.
Now, I want to make a note of a couple things. So when I said that those changes didn't impact that world, we do see that the blue kyber and the dark crystal are still there. The reason that is because Sean made changes in that main branch on his planet. He went ahead and on his computer, he made changes in that main branch, right? And then when he tried to push it up to GitHub, it said, "Ooh, you can't do that. You're not allowed to." So then Sean said, "Okay, well, all right, fine, screw you. I'm going to create my own reality. I'm going to create a branch." So he branched off of that, and that's where we are now. So he branched off of his reality on his planet, which was his computer and the changes that he had made on that main branch. So yes, he is prevented from pushing those up to storage planet, to GitHub, but on his computer, he did make those changes and he's allowed to change that branch. And this is where that metaphor kind of falls apart. But when he created his own reality there, when he branched off, he actually still has those blue kyber and the dark crystal. But I don't. My machine has no idea about the blue kyber or the dark crystal. GitHub has no idea about the blue kyber or the dark crystal. But Sean has created his own branch now. So if he pushes up to GitHub now, where is it going to go? Is it going to go into Michael Brierly Rick's Crystal Garage? It is. It is still going to go here, but instead of one reality, one universe, there are now two alternate realities that will exist inside of Rick's Crystal Storage. So when Sean pushes up his changes,
Should I do it?
let's see. Did you do the git add and the git commit, or do we need to, or is that already?
Oh, I have to do that.
Do a git status, right? Let's do a git status to see what we got. On branch Sean's world. Okay, so here's another command that, you guys don't have to remember right now, but it's a handy one in case you get a little confused, is git log, L-O-G, kind of like a captain's log. So git log is going to show us all of the commits we have made in the past, right? So maybe git log actually might be kind of an important one to learn, just because it does help visualize what's happening here. So we see commit and we see a bunch of long numbers. So that, remember when we talked about a timestamp or the barcode that gets slapped on the box? That's basically what that commit, that yellow commit number is basically like the barcode, the timestamp, just a piece of information that says, hey, at this point in time, 2 crystals were added to the ship because we have the commit, the message that we added there. And then we see Sean's added 2 new crystals, blue, dark, greetings from fuck you. So that came over from when he had done that commit before. So all that information, because when you split off and you created your alternate reality, everything came with you, including your old commit message. So we already did our commit. That's cool. Good. So go ahead and hit Q to exit out of this. So we did our git log to see what was happening. Git log and git status sometimes go hand in hand if you want to look at what happened in the past. Another thing to keep in mind is that time is important. As we travel through time here, we're going to be able to use the ship to time travel as well. And the dates that we go back in time to are those commits, are those receipts and those barcodes that we had. So just keep that in the back of your mind. But Sean has created his commit. Looks like we're good to go. So let's go ahead and run a git push now, Sean. This may not work still. I'm not 100% sure.
Well, push.
Okay, so this makes sense. And Git has given us some help, right? Because we see the current branch, which is our current reality, Sean's world, has no upstream branch. And the term upstream, we can kind of like take away from that means, in the distance, GitHub, further away on the internet. So upstream is on the internet, on GitHub. On Michael Brierly / Rick's Crystal Storage, in my storage garage, I don't know about Sean's reality. He created that on his planet with his portal gun and stuff. And like my repository here, Rick's Crystal Storage, doesn't have that. And if we go and click on, actually, Sean, I'll let you keep going before I share the screen, but you can actually look and see what branches are there in GitHub by clicking on the main, because it'll show you the name of the branch you're on currently. So Actually, to the
I'm talking
left.
about
Yeah, there you go. Thanks. Yeah, that's what I was gonna have you do. So see how we see main there, and it's the default branch. So there's only one reality, and that's main. So GitHub doesn't know about it, and it's kind of like the address of our repository. GitHub needed to know what the address was where we were sending our code, and that was when I had to go in and say, okay, well, I guess I'll create it. So what we can do now is we say, okay, GitHub doesn't know about this reality, Sean's world. It doesn't know about Sean's world yet, but let's go ahead and tell it about it. And the terminal Git gave us some help as to what we can do. So let's go back over to the terminal and see this output here. This is Git. This is Git itself helping us out. So Git says, why don't you do git push -just set upstream origin Sean's world. And you could just copy that if you want. Oh, but there you go. Perfect. That works.
Okay.
Now you don't need to understand all of those words, all those terms, but basically this is just saying, create this, connection to my reality, my branch. I want you to know about my branch. I'm going to tell GitHub about it, and I'm going to push my work up onto my branch. So let's do that. See if this works. Okay. Shoot. So there's a possibility that you don't have access to my repository specifically.
Yeah, I think I don't.
Also, because you haven't pushed up to your own personal. I'm wondering if
have
you
pushed up
created
to
this
mine.
repo. Oh, you have pushed up to yours. Okay, so then it is specifically because mine is kind of a workaround. I'm inviting you to the repository, so that way you should be able to have access. So go ahead and follow that link I sent you in Slack, and then just click on it to accept the invitation. And this should basically update your credentials through GitHub so that you have permission to push to this repository. And sorry that I didn't work this out beforehand, guys, but ideally I want to have this repository set so that anybody can create a branch, and then anybody can push their code up into it. So I guess I just have some protection in place that by default showed up.
So do you have to do that typically, like give people permission? Like, because that would make sense that you have to do that, right?
Yeah, well, I mean, the thing is, it's not protected. It's not a hidden repository, and it doesn't have security on it. I'm kind of surprised that I don't know. We might want to basically make this like a project in our space under the dev delta space. I potentially should have done this under dev delta rather than my name, because it might have default protections because it's my personal repo. So we'll figure that out for when we get to the homework. And I might have to help you guys. Yes. So did you follow that URL? Did you accept the invite?
Yeah. Oh, okay. Did it.
Okay, awesome. So this is, yeah, you can kind of forget that little piece that I had to do to give Sean access, because that's where we'll get everybody to. But Sean had access to push up to his branch. He's not going to have access to push to my main branch, my main reality, but he has access to go to this one. So he pushed up to Sean's world. Awesome. So Sean, go back over to GitHub really quick, and let's go click on that drop down for the branches again. So we see that Sean's world is there. So when we click between those, we're basically opening the portal gun and traveling between two realities. We're saying, what does Sean's world look like? Okay, cool. What does the main branch reality look like? The one that Michael created. And we can go back and forth between realities and see the blue crystals, and then see the blue crystals disappear. See the blue crystals, see them disappear. So we have two realities, and that's pretty cool. And that's pretty powerful, because let's pretend this is a real world example. Let's say that I was in charge of a form, and I had to change a form from blue to red. The background's blue, and the product people wanted me to change it to red. So I go in and I say, okay, cool. I have this repository. I pull down the main primary reality, the main branch. I pull that down to my machine. I get all the updates, anything that's new, and I make my change. I change it from red to blue, the background of the form. Cool. And I've done that on my own branch. So when I pulled it down, I created a branch, and it's like Michael's work to change background color. That's my feature name or whatever. So I create that new reality, that new branch. I do that work there. And as I'm doing that work, Sean has been given a task to change the font size. So he has to go into the same form that's on the same website, and his task is to change the font size to be a little bit bigger. So he pulls it down. He doesn't have my code. I don't have his code. We both just have that main parent, primary master branch, that main reality. He pulls that down, and then he goes in and he says, okay, I'm going to create my branch, Sean's font change branch. And then in Sean's font change branch, in his reality, he bumps up the font size. Now, my reality, my branch, I see a background color of red with the regular font size. Sean's branch, Sean's reality, he sees a background color of white because nothing's changed. And he sees the larger font size because that's the change that he made. Now, we both push our changes up to GitHub, right? We launch our spaceships up to GitHub. And we have 3 realities going at this point. We have Sean's world, we have Sean's font size branch, we have my background color branch, and then we have the main branch, right? So we have 3 realities happening here. And now those are called feature branches, the work that Sean and I did in there. And if we want to say, okay, cool, I like what Sean did, there's a bug in Michael's work. Something is not right. I don't like the shade of red. We want to change that. We can say, okay, Sean, you did great. The person who like manages this repository can say, awesome, good work. I want to merge those 2 realities together. I want to bring Sean's changes in on top of the main branch, on top of that reality. I want to make that, you know, those 2 things are together now because I want Sean's font size bump because he did a good job with that. The way we do that, when I talk about that merging of realities and bringing 2 branches together, is something called a pull request. Have you guys heard about pull requests before? So pull requests is just like that. Basically, the term pull is kind of annoying because it doesn't make much sense why it says pull, because I think the idea is you're pulling the code into that branch. So the main branch, the main reality is pulling Sean's code into it. It's absorbing it like the thing or some kind of amoeba. So it's pulling his code into it and it's a part of it now. In other websites, they call them merge requests because there are other websites other than GitHub actually built on top of the system of Git, which can be helpful for the mental model of how it's just a system. It's not perfect, you know, they're not the same exact thing. I digress though, but a pull request is how we can merge realities together. So let's just follow, it's, you know, GitHub is helping us out here. It says compare and pull request. So let's do it.
Michael, I had a real quick question. I don't know if this matters, but when I went to here, why does it have me there twice?
Sean McKnight added 2 crystals 22 minutes ago, 2 commits. Can you click on the commits thing to see where the little clock on the right-hand side and it says 2 commits? Can you click on those? So this is kind of cool. Actually, I'm not certain why that says Sean McKnight authored and Sean McKnight committed. That could be.
Oh, it's saying I authored and then I also committed. So maybe it's just specifying.
Yeah, that may just be the way that they talk about that. That potentially could be the permissions issue we're dealing with. But this is cool though, because we get to see the history. So that is basically like the zoomed out time machine view. Oh no, you're good. You're good. And you notice that like the icon is even a clock going backwards. So it's like, what has happened in the past? And we see that that's what happened in the past. So very cool. Let's do a pull request though. Let's see what happens. And we want to make sure we're on that branch. So we're, yeah, perfect.
Oh, is that in the wrong place?
No, you're perfect. You're perfect. So go ahead and let's look at this first little piece, those first 2 little buttons with the little funky arrow duders. So we see base, main. So remember the main branch. And then compare Sean's world. Cool. So in my example that we just talked about where they had the font size and the background color, you could have, when you click that base and you click that compare, you could have hundreds of realities, hundreds of branches in there. And you would select which one is done. Some person completed their work in that branch. And we could say, okay, cool, let's see what it looks like if we were to pull those changes into the main branch. So go ahead and scroll down a little bit. And first of all, do you see what you added in Git up there in the text field, the first text field? Yeah. So it took that and said, oh, I know that you added this in Git. You did that in the command line. Cool. I'm aware of that. I am built on top of Git. I'm a website that lives on top of Git. And Git told me that you said this already. So cool. I'm going to put that. I'm going to pre-populate that. You don't need to add a comment in there. It doesn't really matter. If you can be concise with what you did in that first line, then you can be good. So scroll up a little tiny bit before we create this pull request. Oh, that was actually what I wanted to see. I didn't realize it showed it at the bottom too. Nathan, thanks for hanging out, dude. Another dimension. That's good. That's a better way to put it. So this is kind of fun. This is called a delta, actually. So a delta is the difference between 2 things. And we see that our delta is Sean's work because my work, the original file, had Kyber and Kryptonite. Sean added blue and Kyber. If we took those 2 together, and you kind of think about like, you know, transparent 3D glasses, like if you took 2 transparencies and put them over each other, you have a red and you have a blue 3D glasses film, you put them over there, you're going to have, you know, a different darker color in the center, kind of like a Venn diagram. So what's in the center, that darker color, is a delta, the difference between the two, or the, you know, the sum of the two. And these two combined give us this, and it says plus blue kyber plus dark crystal. If Sean deleted kyber and kryptonite and put in the blue kyber and the dark crystal, it would show red lines on kyber and kryptonite. It would say minus this, plus this, plus this. So see how it says 2 additions and 0 deletions. So if he had deleted those 2, it would say 2 additions and 2 deletions. So it kind of tells you what changed. It says, okay, this is exactly what is happening with this merge request or with this pull request. So that's cool. That's what we expected to see. We kind of get to visualize our code. And this is something that Git, the system of Git gives us that. The system of Git gives us the ability to see the difference between the 2 files and whatnot, but it's all text-based. It's all just text that gets crapped out on your terminal. It's totally something that we'll look at in the future, and you can parse through it and get the same information. But GitHub makes it so much easier because we can look at this and it's pretty and it has colors, and we can, you know, we can click through things, and they've given a UI for us to be able to understand this better. So super duper handy. That looks awesome. Scroll to the top and let's go ahead and submit it, because this was basically a preview to our pull request.
Is submitting this?
Yep. So we previewed it. We said that cool. That looks good. We were in kind of an edit mode or just a draft mode. And now let's go ahead and do it. Let's create the pull request. Very cool. So you created a pull request. So I'm going to steal back the screen share.
Sure thing.
Now, and we're going to go take a look at what happened on my side. So I have not refreshed my page yet, but I'm going to go ahead and click refresh here. Can you guys see my screen okay?
Mm-hmm.
Cool. So I click refresh. And first of all, one thing I see that changes is I see that there's 2 branches here now. So there are 2 branches. Very cool. And we also see a little badge next to pull requests, 1 pull request. And if I check my email, I'll probably have some kind of email about it too. So I see, oh, awesome. There's somebody else. Somebody has copied my code, has cloned it, created their own world with a portal gun and made changes to it. Now, I am totally safe. If I was to go into my code and I made some more changes and I push those up, Sean's world is not my concern yet, because it hasn't been merged. The realities haven't been merged together into the main branch, right? So I could still keep doing my thing. I could ignore Sean forever. I could just say, screw you, I'm never gonna merge your pull request. So, you know, I like my code better than yours. That happens all the time. But we see the 2 branches, we see there's 2 different realities happening here. So let's go look at pull requests. I'm saying, okay, you know what? I am kind of curious what he has to add. So this is where we list all. If there were multiple, you just see a bunch here, and you can just click on it, click on the name, and I'll take you into it. Now I'm going to look at this and say, all right, what does Sean do? Okay, so I just see some general information here, just an overview. I see his commit message. If he provided a description, it would show up there. It's not really necessary because this is succinct. Continuous integration, don't worry about that. That's kind of has to do how we get it onto the internet. But this seems to be pretty straightforward. So it has no conflicts with the base branch. We'll talk about conflicts a little bit more in the future. But as a tiny little preview, basically, if Sean changed line 3 and I changed line 3, and we both did those at different points in time, but then we tried to merge our realities together, it would be like realities can't be merged because, you know, somebody tried to change the same thing, you know, like it's basically just saying that I need to know whose takes precedence. Did Sean's change the one that you want in this reality, or is Michael's change the one that you want in this reality? And then we'd have to choose. So that's what a conflict is. In this case, Sean didn't change anything that I also changed. So we have no problems. Like I said, don't worry about that too much. I'm going to go look at the commits here and see what he did. Actually, I'm going to look at the files changed. Sorry. So this is where this is really the important piece here. So I see, cool, this is mine. That looks familiar. Ooh, I see what he added. And I say, okay, cool. I don't have any blue crystals, and I also don't have any dark crystals. So I like that. I like what he added. I like that he put those in my bin, and that he wants to put them in the bin. And I'm going to say Coolio. Okay, got it. And then I say start a review. Actually, it doesn't need to be a full review. I'm just going to finish it. Approve. Okay, hold on. Sorry, guys. Some of this is new. Okay, so I added a comment on there. I really like that Kyber crystal. So one thing, first of all, that I want you guys to all know is that moving forward, this is how we're going to do homework. And I know you guys probably aren't like, don't really care that much, but I think it's really exciting. This is super fun. So this is how we're going to do homework for everything moving forward. So whenever we have an assignment, what we're going to do is we're going to be using Git. Every single assignment is going to have a base project. And as you're going to see with the homework for this one, we have a base project for our CSS joke site. And what I've done is created a super simple website. It doesn't even have any styling on it really, but it has a bunch of links, and you guys are going to add a link that goes out to your website. And you're also going to add a folder with your name that has your CSS and your HTML in the repository that I've created that is a website that's actually deployed on the internet. So you're going to submit pull requests. You're going to create your own branches, submit a pull request, and then I'm going to look at it. And then I'm going to see all your code here. So like your sites, the code that you guys wrote, your HTML and your CSS, just like I see Sean's code here, I'm going to be able to see everybody's code here. And then we can go in and say, if Sean, has an empty styling rule that is bad syntax, I can go in and I can specifically click on it, and I can just comment, which is really cool. I can give him some feedback and say, yo, can you go ahead and delete this? Or why did you do this? And then you guys, because we're all going to be part of the same team here in GitHub, I want you guys to go through, and you guys are going to look at each other's pull requests, and you're going to look at each other's code and add comments and say, oh, cool. Like I didn't know that you could do this with CSS, or I didn't realize that this HTML tag existed. Like, what does that do semantically? I want you guys to have conversations together about your code and work as a team, working on projects together on a big main repository where everybody's code is going to get merged into the same code base, and then it's going to be deployed on the internet. That process is called open source software. And open source software is like the socialization of programming. It's that there are so many people out here who have written amazing code, and we get to contribute to it, and we get to benefit from other people's code. And there's all these libraries that have been written that are free. And there's just this cool, massive world of swirling ideas and innovation and programming. And this is where it happens, is doing this, is when we come together as a team and we get to comment on each other's code, and we get to learn from each other. We can work on big projects, and it's awesome. So this is what we're going to be doing moving forward. This is how homework is going to happen. So let's say that this was Sean's homework. I say, cool, that looks awesome. I'm going to finish this. And I actually approve this pull request. This doesn't mean that I've merged realities yet. This just means that I looked at it and I said, cool, that's fine. And maybe as a team, we've decided that the way that it works is that as soon as a person, a designated person or people have approved a pull request and said, I looked at this, I read your code, and I like it, I think it's good, and I don't think it's going to cause any problems, they can approve it, which basically is just a little check mark saying, okay, cool, looks fine. But they haven't done anything with it yet. And then, Sean himself would be the one that says, okay, now I'll merge it in because it's been approved. You can also set rules where you can't merge until someone has actually approved. So in this case, I'm just going to go ahead and do it, but there's a lot of different workflows, and sometimes that just varies from team to team. So I'm going to merge his pull request in, and yeah, that's my email, confirm. And then I see his thing, and it says merge pull request #1 from Michael Briley, Sean's World. So this is just some messaging for the history for us to be able to, that more data for our time machine. Pull request successfully merged and closed. Cool. You're all set. The Sean's World branch can be safely deleted. So at this point, the reason it told us that is because we have primary reality, right? We have Sean's World over here. Sean's World has become merged in with primary reality. So everything Sean did over here is here. So we have all 4 crystals in our bin, and the main reality has absorbed Sean's. So Sean's is kind of pointless. It's kind of superfluous at this point because it's just the same thing as this. But this is the important one. The main primary world, the main branch is what matters. So we can just delete that. And I can say, you know what? I don't even need to see it. So I'm going to delete Sean's branch because his work is in my repo now, is in the primary main world. So deleted the branch. Cool. So if we go back over to the code, we are going to be able to click in this, and we see that so this text here shows us the most recent thing that happened. The most recent commit message is what shows up here. So if we click on the file, there it is. This is our new reality. Our new reality includes my work and Sean's work together.
So what if you didn't want, what if you like added the stuff and you didn't, but you're like, oh wait, this was a mistake actually. This ruined the code. Like I shouldn't have added this. Is like your old reality just gone now and you're like, you can't get it back? Like the old.
You mean if I merged it and it was a mistake?
Like if you added, so like what if you added blue and dark and you're like, oh, that's perfect. And then as you find out, you're like, oh wait, I shouldn't have done that. That was a huge mistake. What?
I'm so glad you asked. That's great. So if that happened, the reason is because not only does Rick have a portal gun, he also has a flux capacitor from Back to the Future going more layers deep. So his machine is also a time machine. which means that all of those barcodes that we slapped on our crates that had our crystals in them, every time that we load stuff up into the ship and we send it off. And when Sean was doing his committing, he had his own little spaceship where he was putting his crystals in the bin and put the bin in the ship and then sending the ship off. So it's all the same thing happening over and over and over again. So when those things happen, that barcode that we slap onto the outside of the box is what we can see here if we do that git fog command. So this right here, you guys see this? Come in, blah, 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 blah. This is an address in time, basically. So this is basically saying, hey, at this point in time, 40 minutes ago, Michael did this, and it takes a snapshot of everything, the entire repository as it was at that point in time. So if Sean 2 commits later, because I merged in some code of his that I didn't realize was nefarious or had problems with it, we're not screwed at all, because Git is a time machine and it has everything that has happened in the past. It has everything that has happened in the past as long as you committed it. If you committed it, when you commit, it's a snapshot. A snapshot is taken of everything. And there is an address in time to that. So what we could do is we could say, you know what? Let's just go back to that. And I could take this address. Whoops. I could take this address and say, I'm taking this and I'm bringing the whole world back to that reality. I'm bringing the whole world back to that point in time in this reality. I'm saying we're going to delete what has currently happened. You can just go back in time. And then that's all the code you have. That is the real power of Git. There are 2 primary functions of Git that are incredibly powerful. And one of them is the time machine aspect, the ability to go back. I remember how we talked about video games. Like if you wanted to go back in time and you wanted to kill the guy instead of save the town, that's exactly what you can do. If Sean killed the guy, and that was a mistake because then his character can't move forward in the way he wants him to, he can just go back in time, and that commit ID, that SHA, is the save file for his character. He can go back to that character in that point in time and make a different choice. And what he did before doesn't even matter. It's just trash. It's just gone. So that is one of the most important features of Git, is that when we talk about saving files, like, do you guys remember the Mac app time machine that allows you to save a snapshot of your whole system at a certain point in time? So it's not only a backup, but it's also, like it had that cool UI where it was like window, 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 and you could like scroll through and it would show you the date on the sides. You could see like what your computer looked like at a certain point in time. So it's kind of like that, where you can say, ooh, what did everything look like back a year ago? Git allows you to do that. If you've been using Git on a project for 10 years, you can go back 10 years and you can see what the code looked like 10 years ago. It's really cool.
You could go back 10 years and like grab the code to look at it, but would that wouldn't mess it up in the main? And so if I was like, oh, I'm gonna go and like look at this from 10 years ago and I pull it or push it or whatever, and would I end up like deleting all the code that's current now? Or would like
no, so Git is very intelligent. So if you are on your computer, on your machine, and you are on the main branch, on the like primary production deployed to the internet branch, like the one that's the most important, that people create their little branches off of as they work on. But if you're on the main branch, you're like, oh, I wonder what main looked like 10 years ago. You go back 10 years, you're looking at it, the website's totally different. Everything's completely different. The code is completely different. It's interesting, you're checking it out. And then let's say you accidentally ran git add, git commit, git push. Git is not going to let you do that at all, because first of all, you're on the main branch. You probably don't have permissions to do that. Second of all, what it's going to say is you have changes, or you don't have the current information. So that's one of this invisible steps that Git takes when we run a git push that we don't see, is Git says, okay, you want to git push, cool. It checks really fast and it says, let me make sure that there's no new commits that I have on GitHub, on the internet. Let me make sure there's no new commits that you don't have, because if you don't have those, you're not up to date. You need to have the up-to-date information before you are allowed to push anything up. So if you did that, you would have probably 20, 30, 40,000 commits between 10 years ago and now that were not on your machine because you went back in time. So for you went all the way back in time, 10,000 commits in the past. So it says, whoa, you're missing 10,000 commits. You can't push to the branch because you don't have the current information, So that would prevent you from doing that. Git is built in to protect you in that way. But let's say you wanted to create a new website that was old school, 10-year-old version of this app. You could just branch. And if you branch 10 years at that commit from 10 years ago, you created a new reality from way in the past. And then in that reality, you could create a new repository in GitHub and you can push up your own. And you could deploy a website alongside the new one. You could have your modern reality or the modern website. And then you could have a 10-year-old, the version 10 years in the past deployed because you created a new reality with the branch. So branching is really powerful in that sense. So there's this kind of dance and this balance between time and dimensions that are happening. It's very, I don't know. I think it's very sci-fi, but so
Awesome. Yeah.
Git is incredible. It is a huge pain when you're learning it because it kind of hates you. It seems like Git hates you as a user because you're going to say, I'm going to Google this and see what it looks like. And you go, oh, I'm going to go to git.scm, which is like their official documentation. They use the most obscure, entrenched circular reasoning that like is just very difficult to parse through. So find other articles about it if you can. Like there's so many resources about Git on the internet, but even with just what we learned, we're really just looking at 6 or 7 commands here. Everything we did, all of this stuff about traveling in time and creating realities and making pull requests, all of that we can do with these 6 or 7 commands that we created. There's hundreds and hundreds of Git commands that will allow us to learn the buttons and the knobs in this time machine that are really cool, but we don't need to learn those yet because we can just use it. Like the power that you have in your hands from just a few commands is huge. So we're going to move forward with that, and it's going to allow us to turn in our homework and have conversations and build open source software together. So that's what we're going to do. Sean, thank you. Good job, dude.
Yeah.
I love it.